This presentation is for the International Conference on Computational Science and Computational Intelligence. The title of the presentation is Web System for Storing and Visualizing Web Objects in XML. The authors of this work are José Martí Hernández-Salinas, Carlos Roberto Jaimez-González, and Betzabet García-Mendoza. We are from the Information Technology Department of the Metropolitana Autonomous University in Mexico City. This presentation is divided in the following sections. First, I will give you a brief introduction of the work that we are presenting today. I will also talk about the related work. Then I will present Web Objects in XML, WOX, which is a framework for distributed objects and web services. After that, I will talk about the analysis and design stages to create the web system presented today. I will also present the web system in operation, and finally, I will provide you some conclusions on future work. Web Objects in XML, WOX, is a framework for creating object-based distributed applications. It supports the interoperability among different object-oriented programming languages. It uses XML as a format representation for objects, and it uses HTTP as its transport protocol. A web system was developed to complement the functionality of WOX, which allows the storage of distributed objects and the visualization of their state and methods. The web system has a repository in which objects can be visualized and their methods can be executed through a web interface where the user can provide values for each of their parameters. There are some systems that are similar to the web system that we are presenting. Corba Web, SubView Plus, Pesto, Corba Object Browser, and Apache Axis 2. Corba Web is a system that acts as a gateway between the web and the Common Object Request Broker architecture. This system is known as a generic object browser. Its idea is to allow clients to view and invoke methods on any local or remote Corba object through a web browser. SubView Plus is a system to explore a database in order to locate a specific object, retrieve its information, and view it graphically. In addition, this tool visualizes the objects in a hierarchical way and allows navigation in large databases by changing the base object, which is an object that becomes the main node through which the navigation begins. Pesto offers its own interface in which it is possible to navigate over objects. It is designed to explore object databases and offers the possibility of making complex queries of objects in databases through a language similar to SQL. Corba Object Browser allows accessing Corba objects directly from a web browser using a URL. It allows browsing and invoking Corba objects in the same way that users browse the internet. In this tool, it is possible to view and execute the methods of a specific object from a web browser. However, the user has to use a browser called Hot-Java Web Browser, which is no longer available. Finally, Apache Axis is a web services engine, which is interoperable, implemented in C++ and Java. Like WOX, Apache Axis 2 is an open source XML-based framework that uses SOAP for message exchange. Although Apache Axis 2 works with objects, it doesn't save the state of the objects, so its methods are only invoked as if they were static methods. This table shows a comparison of the systems analyzed. S1 represents Corba Web. S2 is SubView Plus. S3 refers to Pesto. S4 represents Corba Object Browser. And finally, S5 is Apache Axis 2. A tick indicates that the system has the feature, while a cross indicates that the system doesn't have it. The features considered for the comparison in this part of the table are the following. Open source, which refers to software that is made freely available and may be redistributed and modified. Interoperability, which means that the system is capable of communicating on different platforms or programming languages. Based on objects, which indicates that the system supports the use of remote objects. Web services, which means that the system supports web services. And use of XML, which indicates that the system uses XML as a means of communication between the client and the server. This is the second part of the comparison table, which shows other features considered. Visualization of objects, which indicates that the system allows the visualization of objects graphically. Visualization of attributes, which means that the system allows the visualization of the attributes that each object contains. Execution of methods, which refers to the fact that the execution of methods belonging to an object is allowed through a web browser. Web interface, which indicates that the system provides a web interface in which the user can view methods of the remote objects. And finally, database management, which means that the system is able to navigate through object databases or repositories. Web Objects in XML is a framework that combines features of distributed object-based systems and distributed web-based systems. WOX uses URLs to uniquely identify remote objects, following the principles of the representation state transfer, REST architecture. This is an important feature because all objects are uniquely identified by their URL and can be accessed from anywhere on the web, either through a web browser or programmatically. WOX uses an efficiency serializer called WOX Serializer, which is the basis of the framework for serializing objects. Requests and responses exchange between clients and servers. This serializer is an independent XML-based library, which is capable of serializing Java, C#, PHP, and Python objects to XML and vice versa. WOX has a set of standard and special operations that are applied on local and remote objects. These operations include requesting remote references, invoking static methods, web service calls, invoking instance methods, destroying objects, requesting copies, duplicating objects, updating and uploading objects, invoking asynchronous methods, among others. The functionality of the web system developed can be divided in a series of actions that can be carried out. For example, access to a specific WOX object over the network. The web system allows its users to access a WOX object stored in the system from a unique URL generated by the same system. With this URL, users can directly access the object without having to enter the repository and search for the desired object among all the existing objects in the same repository. Visualization of objects graphically. Users can visualize through an interface the attributes of a given WOX object. Another one, visualization of methods of any WOX object. Users can view all the methods that belong to a particular object, regardless of the parameters that each method requires to be invoked. Each method has a space to display the response that it returns when it is invoked. Execution of any method belonging to the class of a WOX object. Through the web system, it is possible to invoke any method of a WOX object. There is also a parameter verification to prevent the user from entering erroneous parameter values. This way, it is ensured that a correct invocation of a method. Storage of WOX objects on the server. users are able to upload Works object to the server for later manipulation, either as a parameter for the invocation of an object or simply to store it in the repository. The web system developed consists of a dynamic web interface that allows users to access Works objects hosted in a repository. The user can visualize each existing object in the repository in a graphical way, in addition to being allowed to execute the methods of each object through a web browser. This slide shows the navigation map, which represents the structure of visualization used in the web system. There are some interface prototypes that were developed. This slide shows the interface prototype for the list of objects stored in the server repository, in which the following fields are displayed: object URL, name, reference, and actions, which provides two options to the user. The first option is to view the object's attributes graphically, and the second option is to directly view and access the methods that the object contains. This slide presents the interface prototype that shows the graphical representation of a Works object. The prototype includes a table with a header that contains the ID that makes the object unique and its class. In the body of the table is contained the object's attributes, and there's a button to access the object's methods. In this example, the object ID is 313563317, and the attributes of the object are the following: ISBN, name, author, editorial, and status. Similarly, this slide presents an interface prototype that shows the graphical representation of an object that can contain one or more objects within its attributes. In the case shown, it is an object of type array that contains 3 objects. The methods of each object can be accessed through its method button. In this example, there are 3 objects in the list. Each object has its own attributes and values: ISBN, name, author, editorial, and status of the object. Now, I will show you the web system in operation. Specifically, I will show you how objects are stored in the web system and how they are visualized through the repository. This diagram shows the operation of the web system to store Works objects through a series of steps that are carried out between client and server. In step 1, the serialization of an object with the Works serializer takes place, for which any of the programming languages supported by Works can be used. In step 2, the user proceeds to upload the object to the server by selecting the option Upload an object to the server from the main menu of the web system. In step 3, the server is in charge of storing the object in the directory called upload temp of the web system repository. In step 4, the system proceeds to verify the object. It is deserialized to verify that it doesn't contain errors or that it already exists, and depending on the result, it executes step 5.1 or step 5.2. In step 5.1, the object is moved to the trash if it had errors. In step 5.2, the object is registered in the repository in case it is an object without errors. Finally, in step 6, the user is informed of the result of storing the Works object in the repository. This diagram shows the operation of the repository for visualizing Works objects through a series of steps that are carried out between client and server. In step 1, the user accesses the repository by selecting the option view objects in the server from the main menu of the web system. In step 2, the works rp.xml object is deserialized, which is a list of objects of the works object class that contains the information of all the objects stored in the repository. In step 3, once the works rp.xml object has been deserialized, the information of the register objects can be accessed. So a table is generated that will contain the URL and class of each register object. In step 4, each register object has two options, one to view the object and another to access its methods. Finally, in step 5, the generated table is shown so that the user can choose an object to be visualized. In the interface of the web system, to access the object repository, the user must select the option View Objects in the server, which will take the user to the page shown in this slide. The object repository has 4 columns: the URL of the object in the server, the name of the object, the remote reference to the object, and the actions that can be executed on the object. View object and view its methods. The view object hyperlink displays the graphical representation of the object and its representation in XML. This is illustrated in the next slide. This is the graphical representation of the object on the left and its representation in XML on the right. We can see that we have the root element is an object with the type workstester.biblioteca with ID equals 0. And we have a set of elements, of field elements. This presentation showed a web system that allows storing objects as well as visualizing their state and methods. This web system is a complement of Web Objects in XML, WOX, which is a framework for programming distributed object-based applications. The web system met the objectives set at the beginning of its development because it was possible to successfully design and implement the storage of WOX objects and provide an object repository from which it is possible to visualize through a web browser each object that has been created in it, both graphically and in its XML representation. Future work is necessary to complete the implementation for displaying the methods of any WOX object found in the repository, as well as the execution of methods of a WOX object through an interface where the values for each of its parameters are provided. Thank you very much for your attention.